Bismillahirrahmanirrahim. We continue our discussion on number system and perform further number system conversions. In previous lectures, we performed different conversions, mainly decimal to binary number system conversion and binary to decimal number system conversion. We now proceed with further more conversions. As you all know, decimal number system is native to human language and is generally known as natural number system or very common number system. It consists of 10 total symbols. We can call them digits from 0 to 9. While octal number system, which is not very common and has limited applications, it consists of 8 total symbols or digits ranging from 0 to 7. In today's discussion, we will be performing decimal to octal number system conversion. The method or rule to perform this type of conversion is written in front of you. For a decimal number to be converted to octal number, it requires repeated divisioning method. Now here, the divisioning process will be done with base 8. If you remember, in previous discussion, we performed decimal number system to binary number system conversion, and for that we used divisioning with base 2, and here for octal number system we have to perform divisioning by base 8. So the rule is, given any decimal number system, we need to divide the decimal number with base 8. Keep in mind, this is a repeated division process. Then we will write down the remainders and divide the quotient again with number 8. Why number 8? Because we are going to convert it in octal number system, and octal number system has base 8. So this process will continue until the quotient gets within the range of octal number system, that is between 0 to 7. So if the quotient becomes within the range of octal number system, we will stop our divisioning process. So let's see with examples and apply these rules. Here we have a decimal number 143, and we are to convert it into octal number system. As we just mentioned the rule for this conversion, the rule is any decimal number that is required to be converted to octal number has to be repeatedly divided by 8 until the quotient becomes either 0 or it goes within the range of octal number system. So here's the number 143 as mentioned in the example, and we are to divide it with base 8. So 143, after divisioning by 8, the result is 17 as quotient and 7 as remainder. 17 is again divided by 8, and the result is 2 as quotient and 1 as remainder. Now here the quotient 2 is within the range of octal number system. As you all know, octal number system has range 0 to 7. And 2 is within the range of octal number system. That means it cannot be further divided by 8. So how we write the answer? The method to write the answer you all know is from bottom up. The answer becomes 2, 1, 2, 1, the bottom one, and 7, the top one. So 143 in base 10 is equal to 217 in base 8. This is another example. We have a decimal number 1792 and we need to convert it to octal numbers. The rule remains the same. We need to divide this decimal number repeatedly by 8. Why 8? Because 8 is the base for octal number system. So here we go and perform this divisioning. 1792 is divided by 8 and the result is 224 as quotient and 0 as remainder. 224 is further divided by 8 and the result is 28 as quotient and 0 as remainder. 28 is then again divided by 8 and the result is 3 as quotient and 4 as remainder. Now here you can again see 3 is within the range of octal number system and it cannot be further divided by 8. So how we write the answer? Here we stop this divisioning process and start writing the answer. The procedure to write the answer is from bottom up manner. The result for 1792 in base 10 is equal to 3, 4 which are written here at the bottom and 0 zeros are written here at the top. So collectively we write it as 3400 in base 8. I hope you have understood this conversion process. Now we are going to convert the decimal fractions to octal number system. So if we are given a decimal fraction, what is the procedure to convert it into octal number system? The rule is written in front of you. We are going to multiply the fractional part successively with 8. This is similar to when we were performing decimal to binary number system, and in that the fractional part was multiplied successively by 2. But here since we are performing octal conversions, so same multiplication method will be followed, but the number will be 8 instead of 2. The multiplication will be done by 8 instead of 2. Next we are to note down all the carries generated until the multiplication of the fractions become either 0 or the fractional parts starts repeating itself. So when we are to stop the multiplication process, if the fractional part becomes either 0 or it starts repeating itself, that means it has become a recurring product. So no matter how long you perform the multiplication, the result will remain the same again and again. One thing more, few among you have asked that they are getting non-terminating results of multiplications in previous lecture. So keep in mind, if you are getting non-terminating results, or if the results are getting too long, you can perform 5 to 6 multiplications and write the answers with 3 dots. That means this result is not terminating, or simply you can say the result goes on. So let's apply these rules on the example. We are given a decimal fraction 0.01 5625, and we are to convert it to octal number system. As you know, the method is repeated multiplication by 8. So we are to multiply 0.015625 with 8, and the result is 0.125. These are the carries that we are going to note down and multiply this fractional part again by 8. So 0.125 is multiplied by 8 again, and the result is 1.00. Here you can see the fractional part has become 0. As we mentioned here, when the fractional part becomes 0, so that is the point when we are to stop this multiplication process. So now we have to write the answer, and answer, as you know, has to be written in top to down manner this way. The answer for 0.015625 in base 10 is actually 0.01 in base 8. Another example for decimal fraction, and we need to convert it into octal number. The number is 0.523. We need to convert it into octal number system. The method would remain the same. We would multiply this fractional part with 8 successively. So 0.523 is multiplied by 8, and the result is 4.184. This 4 is carry which we are going to note down and multiply this fractional part again with 8. So 0.184 is again multiplied by 8, and the result is 1.472. 0.472 is again multiplied by 8, and the result is 3.776. 0.776 is again multiplied by 8, and the result is 6.208. 0.208 is again multiplied by 8, and the result is 1.664. 0.664 is again multiplied by 8, and the result is 5.312. So here you can see we are not reaching to the end of the result. So the result is non-terminating. Again, if you multiply 0.312 with 8, and the result would be 2.496. The more you would multiply, the more numbers will be generated. So it's a non-terminating result. So again, 0.496 is multiplied by 8, and the result is 3.96. So the more you will multiply, more numbers are going to be generated. So I stop here this multiplication process and write the answer with 3 dots. Here you can see how we write the answer in top to bottom manner. So 0.523 in base 10 is equal to 0.41361523 and so on. So these 3 dots actually means the result is non-terminating and it goes on. But don't remember to write this base. So it is base 8. I hope I have answered your question which you were asking in previous lecture. So this is the procedure if you are getting a non-terminating answer, or if the calculation is going too long, so you can perform 5 to 6 multiplications or calculations and write the answer with 3 dots, but don't forget to write the base. Now let's merge both the integer and fractional part. So we have a decimal number that has an integer part 73 and a fractional part 0.625, and we are to convert it into octal number system. So here we need to perform two separate conversions. The integer part will be converted by successive divisioning method, while the fractional part will be converted by successive multiplication method. In both the cases, either the divisioning or the multiplication, the base would remain 8, since we are going to convert it into octal number system. So let's first convert the integer part. Integer part here is 73. So we are to divide this 73 by 8, and the result is 9 as quotient and 1 as remainder. 9 is again divided by 8, and the result is 1 as quotient and 1 as remainder. Now as you can see, this quotient, which is 1 here, is within the range of octal number system, and it cannot be further divided by 8, so our division goes stop here. We need to write the answer in bottom up manner. But before writing the answer, we need to convert the fractional part first. So the fractional part is 0.625, and it requires repeated multiplication with 8. So 0.625 is multiplied by 8, and the result is 5.0. Here you can notice the fractional part goes to 0. That means we cannot proceed further. Our multiplication also goes to end here, and we write this multiplication answer from top to down manner. So for writing the answer, we need to merge these two parts, both the integer and the fractional part. 73.625 in base 10 is equal to, 73 has been converted to 111 here, bottom up manner. So 73 is equal to 111, point remains same at its place, and 0.625 is equal to 5 here. We had written the answer in top down manner. So 73.625 in base 10 is equal to 111.5 in base 8. This is another similar example. We have a decimal number having an integer part and a fractional part. So for integer part, we need to perform successive divisioning by 8, while for the fractional part, we need to successively multiply with 8. So 965 is the integer part, and we need to divide it by 8. The result is 120, and remainder is 5. 120 is again divided by 8, and the result is 15, while the remainder is 0. 15 is again divided by 8, and the result is 1 as quotient and 7 as remainder. Now this 1 is a quotient which is within the range of octal number system, so it cannot be further divided by 8. Our divisioning process stops here. We need to write down the answer in bottom up manner. But before writing the answer, we need to perform the conversion of fractional part. The fractional part requires repeated multiplication. So 0.198 is multiplied by 8, and the result is 1.584. We need to store this carry and multiply this fractional part with 8 again. So 0.584 is again multiplied by 8, and the result is 4.672. 0.672 is again multiplied by 8, and the result is 5.376. 0.376 is again multiplied by 8, and the result is 3.008. 0.008 is again multiplied by 8, and the result is 0.064. 0.064 is again multiplied by 8, and the result is 0.512. 0.512 is again multiplied with 8 and the result is 4.096. So again here you can see it is a non-terminating result. The more we are multiplying, the more we are getting the products. So after performing 5 to 6 calculations, you can stop the result here and write the answer in 3 dots. 0.096 is multiplied by 8 and the result is 0.768. 0.768 is again multiplied by 8 and the result is 6.144, and this goes on. 0.144 is again multiplied by 8, so you will get 1.152. So if you multiply 0.152 again you will get another product, and this is a non-terminating result. So we stop here. I have performed actually more. You can perform 5 to 6 calculations and stop. So the method to write the answer is in top to down manner. So we need to merge both the answer, the integer part and the fractional part. 965.198 in base 10 is equal to, we have to write the answer for integer part first. Integer part was 965. So 965 is equal to bottom up manner 1705. Point remains at its place here, and 198 is equal to, we have written the result in top down manner like this, and 0.198 is equal to 0.145300406 with these 3 dots. That shows the result goes on. But at the end, don't forget to write the base. It is converted in. So I hope you must have understood, if you are getting a non-terminating result or if you are getting result that is too long, so how you can manage the answer. This is your assignment. You need to convert these decimal numbers into their respective octal numbers. Assignment will be uploaded on KCMS and you can submit this assignment either on KCMS, and if there is any problem in submitting your assignment on KCMS, you can also email me your assignments. You can find my email address here. That is all for now. I thank you all.